For this example, the Thevenin equivalent needs to be found. So the first step is to find the open circuit voltage between the 2 points you're trying to find here, A and B. So we want to find VTH. VTH can be found if we knew the current through this one. I'm going to label it as I1. We would have I1 times 10 is VTH. So in order to find I1, note that a current summation will produce an equation with I1 and IX. So coming in, I have a minus IX plus 2IX plus I1 equals 0 as my current summation. And then I can take a voltage loop around the outside. If I start here, and I take my voltage loop, and the bottom is going to be all one node, so that will get me to the beginning again. So I have, going in this direction, plus 10 minus IX5 and then minus I1 times 10. So plus 10 minus 5IX minus I1 times 10 equals 0. And I can solve these equations. So I can put from this one, I have the I1 is equal to a negative IX. 2 minus 1 is a positive 2, and then I take that over to the other side. And I can plug that in for this IX. So I have 10 minus 5 IX, or I want to solve for I1, so I'm going to say that negative I1 is equal to IX, and then negative 10 I1 equals 0. And then I can combine the terms. So that I have a minus 10 and a plus 5. So I have a minus 5I1 is equal to, or if I take the minus over, it will become a plus. And I get that I1 will be equal to 10 divided by 5 is 2 amps. So then we know that VTH then will be equal to 2 times 10, so I get 20 volts. So this would be my answer for VTH. The next step after finding VTH is to find RTH. And the second method is to put on a test source. When you place on a test source, you have to short or put to 0 the independent sources, which would be this 10 volts would go to 0. So I'm going to place either a voltage source or a current source here. I'm going to do a voltage source, and then I need to find this current, which I'm going to call IT. Now, by placing a voltage source there, make sure you leave your dependent sources in the circuit still. So by placing this voltage source here, I now know the current here and the current in IX. IX in this case will be a negative, and this is a positive on the top, so it will be a negative 1 over 5. And I know the current here, which I'm going to call again I1, is going to be 1 over 10. So to find the current IT, I can do a current summation. I have a minus IX plus 2IX plus I1, and a minus IT equals 0. and I solve this then for IT. IT is going to equal, and I'm going to plug in the values, 1 over 10 for I1. This becomes a plus IX, so a minus 1 over 5. And I combine this to get this. This will be 2 over 10. So I get a minus 2 over 10. So I get a minus 1 over 10. And RTH is going to be the test source you put in 1 over that current IT. So it will be 1 over So 1 over IT, which will be 1 over 10. So again, I get 10 ohms. And don't worry about the negative. It doesn't change the value for RTH. So we get again 10 ohms for RTH. So our Thevenin equivalent will now be the voltage source and the resistor. A and B locations in the circuit remain the same. I have 10 ohms here and 20 volts here. And that is the end of finding the Thevenin equivalent.